Dave, I'll steal the screen share from you if that's all right with you.
Yeah, absolutely.
Um,
I need to stop the share.
yeah. Yeah. So, good. I don't know. I guess it's still morning for y'all, for many of y'all, but good morning. Thanks for joining us. I know it's Saturday, so we appreciate you joining us. I don't know what the weather's like out in on the reservation, but here it's a beautiful day. So I hope it's a nice day for you, and we can. So we appreciate you coming online when I know you have a lot of things going on. So oh, good, good. It's beautiful there too. Wonderful. Okay, so yeah, my name is Kim. I work with Dave at Kansas State University. As Dave mentioned before, I've been out to the camp that the Navajo Math Circles runs 4 years now, and I love coming out and meeting your students, and we have a great time. Looking forward to coming again this summer with my family, and yeah, we just always have a great time doing math with the students, and they always surprise us in all different sorts of ways. So I'm going to work through an activity today that I haven't run in a circle yet, but I will send the link to a document that has kind of the questions that I'm sharing here. So there's a link in the chat if you want to just look ahead at the questions, or if you want to use this later. I also sent it to Dave. He likes to post these resources as well. So basically, it's just a collection of fun problems that relate to divisibility and place values. And things to get you to think about these concepts in slightly different ways and to use different tools. So I will share my screen with the version that I have. Cool. Great. Let's see, let's see. Okay, so usually how we run a lot of these math circles, as you might have seen in previous sessions, is kind of just much more hands-on and interactive. And so yeah, so that's how I've collected these problems to be hands-on and kind of thinking through some things. So so here's the first problem, and the first problem bunch of problems relate to something like this. So Professor Dave Ockley likes to display his interest in math with a special vanity license plate. His plate has 6 digits, one, two, three, four, five, and six. None are repeated. And it has the following properties. So the first 2 digits in the plate are divisible by two. So here you can see we have like these one, two, three, four, five, six spots for to place each of these 6 digits. And we know these first 2 digits are divisible by two. And then the first 3 digits are divisible by three. The first 4 digits are divisible by four, and then this is divisible by five. And of course, the whole thing should be divisible by six. And we want to figure out what Dave's license plate number is. So I'll leave the question up here for a minute. And again, I sent that link in the chat too, so you should be able to see it there if you want to use that Google Doc in any particular way here. But maybe, I guess, are there any questions about how the question is phrased? Or do we understand the question? Do you think, at least we think so, so far? Good. Okay, so let's take maybe at least 5 minutes and let's all just kind of play around with it. See if you can, nail down any of the digits and think about the question for just maybe 5 minutes or so. Let me check the one person said. So if you found one, I know a couple people put some in the chat, a couple of suggestions in the chat. Um, you could even scroll ahead a little bit, but one of my questions will be, uh, sorry, what my next question would be, is that the only one? Maybe you can check other people's and see if theirs is correct, if it satisfies this criteria. And so my next question would be, is that the only one, the only solution? And now some of the answers I'm getting here, so I should point out too, so you do have to use all six digits, right? Because it should have six spaces here, one, two, three, four, five, six. And then we're only using the digits one, two, three, four, five, six. Okay, so think about whether your answer satisfies that. Okay, I've gotten quite a few answers in the chat here. How are people doing? Do we need another minute or two, or you can always raise your hand if you're like, don't rush me. Okay. Um, okay, um, so maybe I'll just pull one of the answers because we've got a lot of answers in the chat here. And I'll just pull one from the chat unless people want to unmute and throw one at me. That's also fine. But maybe let's just talk about like I'll grab this one. I think I saw something like this. Um, okay. So someone gave this answer. Um, and I think this answer doesn't quite work. Does someone want to tell me why this answer wouldn't quite work? How does this break the rules of the question? Feel free to. Oh, good. Oh, someone put it in the chat. Thank you. Perfect. That's perfectly great. Feel free to unmute yourself as well or raise your hand. Um, okay, so one person said, eight is not included. So, good. So, eight is not included in this list. We want to only use use these numbers, these digits, 1, 2, 3, 4, 5, and 6, not 7, 8, or 9. Um, and I think that's correct. So that's one way I knew right away that did not quite fit. Um, and good. I think that one doesn't work for that particular reason. Um, let's see. I saw some other good answers. Let's see. Okay, so let's pick another answer that doesn't quite. So 0 and 8, right, are not included in this list, so we can't use numbers that have that. Let's see. Let's see. I've seen a couple right ones, so I just want to look at. What about this one? Okay, this one definitely uses 4, 6, 2, 1, 3, 5 is one that someone wrote. So that has all the correct digits, right? 1, 2, 3, 4, 5, and 6. Uh, Nothing is repeated. That's also correct, right? We had each number appears only once. Does this one work? Someone says, I think Amelia is on it. She says, uh, it's but not divisible by 6. Amelia if you don't mind unmuting yourself, do you mean the whole number, or what did you mean by not divisible by 6? Good. Good. The whole thing. Right. Good. Good. So the whole number, right? So remember my rules were that this had to be divisible by 2, this had to be divisible by 3, 4, 5, and the whole thing had to be divisible by 6. And so maybe we can also just refresh on some of our divisibility rules that we have, right? To be divisible by 6, we need that the whole number should be divisible by both 2 and 3, right? And we can already see this number is not going to be divisible by 2 because it ends in 5, right? It's not. And I think someone also pointed out another thing that they caught, which is that it's also not this number is not divisible by 5. I think I also saw as a comment. So definitely it's not divisible by 5 because there's a 3 here, right? Do we see this? Very good. Okay. Questions so far about the conditions or anything that I'm saying that seems unclear? Okay. Good. Okay. So I like this comment about divisibility by 5. That was actually the first one that I had caught as well, that this number is not divisible by 5. And do we remember what is our rule for divisibility by 5? Um, yeah, I'm seeing Maria's on it. She's mouthing it to me and everything. Perfect. Um, it's this digit should be either a 0 or a 5. And we know it can't, yep, exactly. It ends at either a 5 or a 0. And so this digit has to be a 0 or a 5. 0 is not one of my options. So that actually forces one choice, right? This number has to be the 5, is what this tells me. I have no choice. Good. Did anyone notice that observation or when they were going through? Okay, cool. Good. So this was one kind of strategy that I had started off with when I worked through this problem. Um, so I did notice a couple of correct answers in the chat, which is amazing. And let me see. Yeah, okay, so my plan was to possibly discuss strategies in breakout rooms. Dave, are you on still, or did he step away?
Yes, I'm still on. I just was muted.
Okay, yeah, perfect. I was thinking about discussing strategies
Oh,
in breakout rooms in smaller groups. Should we
sure.
try that, or what do you think? Okay,
Um,
cool.
let's see. So I think Desiree had suggested she could lead one. Is anybody else shout out to me? Like I'm not seeing Michelle. Whitstone. So let's see. I could run a breakout. You could run a breakout.
Hmm.
Desiree could be one, and that would give us three rooms with and I
Yeah, if
guess
it's logistically too rough, then we can also
yeah,
stay all together. That's also fine.
yeah. I just seeing is oh, Elvira, Denny. Sorry. Let's see if
Mhm.
Elvira's here. Elvira, do you hear me? Are you here?
It looks like that. Yeah, maybe it's
Looks like,
logistically a little rough.
yeah, it would be one for you and one for me. We could cut it in half if you wanted.
Yeah. Okay, yeah, we'll just stay all together then. It's totally fine. I just was seeing um how this would go. Good. So I think I saw very good. Okay, so Um, good. So this is kind of one strategy we picked out in getting this number, and I've seen a couple of correct answers here. So I think someone just put one again that was put up earlier. Maybe it was even the same person. Good. So it looks like Jason just put. I think this one. Well, 'cause if I'm correct, we can double check. So we can check it together. And let's look at this number. One. 2, 3, 6, 5, 4. Well, it definitely doesn't break my five criteria that I put in here, so that's good news. Um, and now I need to check all of the other things. So maybe I'll give you a moment to check yourself and see if you think this works, or if you think this one does not work. And you can let me know what you think. Maria's giving me a thumbs up. Love it. Thank you. Amelia says it works. I'll give everyone else a chance to think for a second. Getting a few, it works. Correct. Awesome. Okay, so let's try it together. I'll test it with you guys just to make sure we see. Okay, so um, this thing had to be divisible by 2. Looks like 12, definitely divisible by 2, right? 12 divided by 2 is 6. We're good. We can also see that this second number is even, so we're okay. Okay, divisibility by 3, that rule is a little bit tricky. So if you remember, for a number to be divisible by 3, do we remember what that rule is? How does that work? Very good. The sum is divisible by 3, the sum of the digits, right? So that would mean that 1 plus 2 plus 3, this number should be divisible by 3. So we can check it off to the side. So 1 plus 2 plus 3, I think that is 6. And 3 divides 6 just fine, right? So we have this is divisible by 2, this is divisible by 3. I need this number to be divisible by 4. And for that to be the case, I think the last two digits need to be divisible by 4, right? So that's that rule here. So I can also write some of these rules off to the side if that's helpful. Um, so 3 divides a number if um, the sum of oops, the digits is divisible by 3. And we said 4 divides a number if it divides the last two, the number made by the last two digits. Okay. Okay, so those ones are a little bit strange. Cool. A slightly less common than 5 and 2 that we use all the time. Okay, so good, so good. So we need 36 to be divisible by 4, and I believe that it should be. Is that right? 36 is divisible by 4? Looks like I think that's 9, right? 9 or 36 divided by 9 or by 4 is 9. So that seems good. And then we said already this number had to be 5. That's how we were going to know it was divisible by 5. So that one's good. And so the last thing we need is that the whole number is divisible by 6. And in order to be divisible by 6, right? So 6 divides a number if 2 divides the number and 3 divides the number, right? Both of those things happen. Well, 2 definitely divides the number because this thing is even. And so we have to check that 3 divides the number. So we should check that 1 plus 2 plus 3 plus 6 plus 5 plus 4 is divisible by 3. And let's see, this is 9 plus 6 plus 6. And so that should definitely be divisible by 3, right? Cool. And so this whole thing should be divisible by 3. Good. Okay, good. So this number works, right? Yay. And maybe this is Dave's license plate, right? Only I know because I'm Dave's neighbor, so I could go look at his license plate. So then the question is, are there other possibilities? Okay. And I think we saw some other options there that would be correct. And so I think at least one other person proposed a good solution. Um, and if you found that solution, awesome. If you did not find a different solution, maybe try to and see. We'll take another few minutes and see if, I guess, two questions we want to answer. One, if there's another solution, if there is another solution, what is that other solution? Yeah, Dave? Oh, Dave, did you mean to unmute yourself? Oh,
Oh,
I think he did.
sorry.
Dave? That's okay. Um, so, uh, so take a couple minutes. If there's another solution, try to write down what that other solution would be, or which of the other ones you think would be a solution. Um, and then if you find that thing, or if you already found the other solution, is there going to be a third solution, or is there a third solution that you can come up with? So I think there are two solutions. This is one of them. See if you can find the other solution, and tell me whether or not there's going to be a third solution. Okay. So we'll take a few more minutes and think about that. Okay, it looks like at least a bunch of people are seeing what this other solution is. So maybe I'll just kind of rearrange my things. I had formulated this question a little bit differently than I even phrased it here. So I said that I was jealous of Dave's license plate, which maybe was this thing, 123654. And as Amelia pointed out, that we could actually rearrange the first three digits, and we can get another solution. I think it's the first three digits that work here. So I think another solution I've seen a few times here is 321. Oh, sorry. Yeah. 654. So these last three digits are staying the same. So we're definitely satisfying the fact that this number should be divisible by five. Or sorry, these three, there's first five digits should be divisible by five. And we can check, right? Once you've seen some of the solutions, you can quickly check whether or not they work, right? So we see this number is definitely divisible by two since it ends in two. This number is divisible by three since the sum of the digits is three plus two plus one is six, right? That didn't change, still divisible by three. Uh, this number needs to be divisible by four. And that means these last two digits had to be divisible by four. And 16 is divisible by four. So so far, so good, right? We're all the way up to oops, these four digits. And we said the fifth digit that works because that one we knew had to be five. And then altogether, the whole thing had to be divisible by six, which means it has to be divisible by about two and three. So, well, it's definitely divisible by two since it's even. And then we take the sum of the digits and we see that's also divisible by three. So what strategies did you use? Did you use any other, did you come up with any strategies for finding this number? Or if you found this one already for trying to find a different number? We noticed, for instance, like one of our strategies is that we kind of noticed that we already said something about how this number had to be five, right? Because in order for the fifth digit to be, or for the first five digits to be divisible by five, the last thing had to be zero or five, and there's no zero, so it had to be five. Were there any other strategies or things that you used in coming up with your other solution? Or did we just use guess and check? Okay. So Amelia said something about common sense. Okay. Yeah, guess and check or trial and error. Uh, so maybe we can say something more about uh, so uh, so common sense, I think maybe can mean a few different things to different people, right? What is common? And so can you maybe elaborate more on common sense or any other kind of, I think, reasoning that you might have worked through for this? So, like one question I have, for instance, is so Amelia had pointed out that you can change the order of these first three numbers, right? And when we did this, we can then test, of course, does that number still satisfy all of these conditions? But one nice thing about changing the order of these first three numbers is that it doesn't affect whether the whole thing, or sorry, whether these first three numbers are divisible by three. Why is that? I'll write my question down maybe in a different way too. Or maybe another way to say it. Good. So Jason said they have the same sum. Very good. So one way I kind of wrote this as a little bit of a vague question, but good. So uh, as far as my divisibility by three condition is, well, 1 plus 2 plus 3 is 6. So this thing is divisible by three. But that has the same exact sum as 3 plus 2 plus 1. It's still 6. So this number will still be divisible by three. So um, so I asked this question a little bit vaguely. I said, I've actually, how I wrote it was, does the order of the first three digits matter? And for that condition, not really, but it does matter a little bit because we also need these first two things to just be divisible by two. So could I have, so can I have the first three digits be, so here's my next question. Can I have my first three digits look like uh, um, 3, 1, 2? Ah, the two matters, right? So I do have to be a little bit careful. I think Russell might have already seen what I was asking here. So good. So these will have the same sum. This still will be divisible by three, but we notice that the divisibility by two condition will no longer work, right? So the answer to this question is definitely no, right? Good, good. This two has to stay in the middle. Very good. Um, Wonderful. Um, okay, were there any other things that you might have picked up on as you were working through this problem? Any other patterns or maybe common sense strategies that you might have picked up on as you were trying to reason through? Okay. What about, so we know that this number had to be divisible by three, right? Um, and so, uh, one thing that I noticed as I was working through this was, yeah, this number has to be divisible by three. This whole number has to be divisible by six, right? And so that same kind of idea where the order of these, since this whole number has to be divisible by six, it also has to be divisible by three. And so the order of these terms doesn't really matter as far as divisibility by six. Whenever I add 1 plus 2 plus 3 plus 4 plus 5 plus 6, I get a number that's divisible by six. So it doesn't really matter what, sorry, divisible by six, sorry, divisible by three, I should say. I get a number that's divisible by three. And so whenever I add the digits, no matter what order, it's a number that's divisible by three. So actually, all I need to check for this last term is that it is even, right? That this thing is divisible by two, because I need this whole number to be divisible by three and by two. No matter what order I put these numbers in, it's going to be divisible by three. So I only have to check that this thing is divisible by two. Good. I was trying to think of some other strategies that I came up with. So I did some guessing and checking. Anything else that I might be missing that people came in with for a strategy? Cool. Okay, great. Um, okay, so I feel like I saw a few other answers. So we have these two answers. So we talked about strategies. Okay. So the next question is, okay, so we found two solutions. I'll kind of zoom out here so we can see both of the solutions, right? This one works, right? For Dave's license plate, then I would take this license plate because that sounds really cool. And great. So you're now saying, well, Dave and Kim are the coolest people and they have the greatest license plates. I want to have a similar license plate. Could you come up with the same? Is there a third one? And So I know there have been a few other things spouted out here as potential solutions. Does anyone have one that they think still might be a solution that did not come up yet that I might have missed that they could use as their really cool license plate? Does anyone think it's not possible to come up with another one? Mm. Okay, so maybe we'll take a show of hands and see who thinks that if I had enough time, I might come up with one. Um, Maybe, raise your hand in the little, I think there's a little button at the bottom that says raise your hand or hit some of the one of the little emoji dudes, whichever one you like. Who thinks I could come up with one if I had more time, or like there probably is another one. I'm just not thinking of it. Anybody think that might be the case? At least, yeah, perfect. Thumbs up works. Great. Okay, good. Getting some thumbs up. Good. And then who thinks? I'll wait for those to. Perfect. Thank you. Got a few people thinking, "Ah, I just need more time, but I don't have it yet, but there's probably another one. And does anyone think that there's just not a third license plate that fits this criteria? And who feels very unsure? Now show your hands if you feel very unsure and you're paying attention, but you feel like I'm tricking you. Yeah, thank you, Maria. Appreciate it. Good. And Darren. Fair, fair. Okay, I mean, Amelia put in the chat here that she thinks it's the only possible answer. And let's see. Do you have any reasoning for thinking it, or is it our common sense speaking to us? Can we be more explicit about our common sense, Amelia,
Hi,
or
Kim. Good
anyone?
morning. This is Amelia.
Hi,
I,
hi,
I,
Amelia.
I, no, no, I was just writing sometimes common sense because the condition that you mentioned earlier is
Yeah,
of the first three digits. That's what I mean. So
yeah,
the
yeah.
first three
Perfect.
digits can
Exactly.
only be possibly interchanged, but other than that, that's why I
Beautiful.
said it's common sense. But
No, I
that's,
knew what you were. I knew you were saying something like this. I just wanted to be
yeah,
exactly.
that's the one that I'm trying to say. But
I
when we
want you to
talk
give me the
about
words.
Yeah, but when we talk about math, there are some other
Uh-huh.
things that we need to consider. Especially you mentioned about divisibility. We should be aware of the
Yeah.
rules. So
Yes.
I'm sorry if I wrote the word common
Oh,
sense.
don't be. I'm sorry. I didn't mean to give you a hard time. I was just trying to
All
get you
right.
to talk to say it. Sorry. I hopefully didn't get the
Thank
impression I was
you.
trying to. Yeah, yeah. Sorry, Amelia. I'm trying. You're giving me great answers. That's why I don't mean to be
Yeah,
picking on you.
I'm just
Thank you.
referring to the first three numbers. Thank you.
Yeah, no, thank you. Sorry. Good. No, thank you, Amelia. Sorry about that. I liked your answer. I think you knew more. That's why I was trying to get you to say more. You're doing great. Um, yeah, no, that's what I figured you meant by common sense. But putting those things into words sometimes is really hard, right? And so I was trying to get you to say a little bit more to help me put these things into words, but you did great. Good. So I think I had another proposition. So Arnold asked about this number 432651. What about this number? Do we think won't work, or do we think will work? We definitely have the five in the right spot, but the last number needs to be even, right? Very good. So this number needs to be even. it should be 2, 4, or 6 in this case because for this whole number to be divisible by 6. Very good, very good. Yes, thank you. So that number won't work. And yeah, I don't think I've seen any of the ones that might work through this. Um, and so, and I think I'm pretty sure I'm pretty sure there aren't any other solution that will work through this. Um, and so the way to be sure that there wouldn't be any solutions is to kind of work through. I mean, you could try to. There's a few ways, right? So one way is a strategy we've mentioned a few. I saw a few people mentioning is like a trial and error, right? So we can guess and check every single number. But that would take us a while if we just guessed every single number, right? So just putting all of testing every single so strategies. Let's talk about strategies here. So strategies. So can you find another combination that worked? No. So let's just talk about these strategies a little bit. So um, trial and error. Uh, so trial and error is a great strategy, and it might have gotten you one or even both of these solutions, right? Uh, uh, can get a solution or two or three if there are three, right? Um, but if we wanted to know that there are no other solutions, um, it's going to take a while. Um, to test every single one. And so that's why we like to have this strategy. Like so one of our strategies was so what do we some things we noticed were a 5 should be in the fifth spot. Oops, can't spell. And we noticed the first 3 digits should sum to, well, something that's divisible by 3. Can the first 3 digits, we saw that the first 3 digits were summing to 6, right? That's definitely divisible by 3. So 6 was a great option. That worked. Could the first 3 digits sum to 3? What would the first 3 digits need to be in order to sum to 3? Right. What would the first 3 digits have to be to add to 3? Well, the first 3 digits would all have to be one, right? In order, or some combination was or zero, right? They'd all either have to be the same, they don't have to be one, or have to have zero in there somewhere. So we're never going to have them sum to 3, but they could sum to 6. Could they sum to 9? They could probably sum to 9, right? Because let's see, um, there's got to be. Is there a way? That's a good question. Could they sum to 9? 6 and 2 and 1, I guess, would sum to 9. That seems possible. Oh, can we? Can they sum to 9? What are the ways we could sum to 9? 6 plus 2 plus 1. Um, could be possible, potentially. Uh, is there any? So 5 plus 3 plus 1, right? Um, 4, hmm, 4 may not work. 5 plus 3 plus 1. Uh, anything else? 4 plus, what else am I missing? Am I missing some others? Because if I did 4, I'd have to have 3 and 2. That would work. 4 plus 3 plus 2. Okay. Those guys would work. Cool. So it makes maybe it's possible that they could sum to 9. Could they sum to 12, I guess? Possibly they could sum to 12, maybe? Like 6 plus 5 plus 1 or something like that, right? What about 15? Do you think the first three numbers could sum to 15? Let's say maybe I take my biggest number, 6. Well, the next biggest number I can add to that is 5, right? Um, and 6 and 5, that's 11. 4, right? 6, 5, 4. Very good. Thanks, Jason. 6, 5, and 4. Good. But I don't think I could sum to anything bigger than that, right? So this is the only way I could sum to 15 because those are the biggest numbers I've got. So I think these are possible sums for those first three numbers. Cool. So Jason mentioned actually another really great strategy that I saw in the chat. And he said that the second, fourth, and sixth numbers or digits, sorry, should all be even. So I'm going to write that down here. Sorry, I started writing it down because I didn't want to forget to say that. But the second, fourth, and sixth digits should be even. Great. And we know that because the first two digits had to be divisible by 2. The first four digits had to be divisible by 4, and all six digits had to be divisible by 6, which means they're, in each case that they all had to be divisible by 2, right? Very good. So uh, that's actually a really helpful strategy because it tells us we actually only have how many, I guess, here's my question. So the second, fourth, and sixth digits should all be even. And how many even numbers digits options do we even have? Well, we have 2 could be in one of those places. We have 4 could be in one of those places. And we have 6 could be in one of those places. But we don't have 8 to use. And we don't have 10 to use or anything beyond that, right? So it means that 2, 4, and 6 have to go in the second, fourth, and sixth spots. So once I decide, so this actually is pretty nice as far as a strategy that Jason pointed out here. So let's say I have my one, let's see, and maybe this is something, again, sorry if I was picking on you earlier, Maria. I think this is something that you had in your head and you're real smart, and I wanted to just pull out what your common sense was. So let's see, we have 1, 2, 3, 4, 5, 6, right? Okay, so this is my so I know in this spot, and this spot, I have to reserve for 2, 4, and 6. So in these spots, there shouldn't be a 2, 4, or 6. Otherwise, I'm not gonna have, anything left over. So these numbers should all be odd. Um, these things should be odd, and the purple spot should be even. Okay, great. So the circled spots should all be odd and the other spots should be even. So actually that actually tells me quite a bit about what some of these sums. For instance, if I now look at the first three digits, um, um, that actually tells me that some of these combinations that I was looking at aren't going to work. For instance, one way to get 9 is 6 plus 2 plus 1. And I think that I can't have 6 plus 2 plus 1 here. Why can't I have 6 plus 2 plus 1 here? Or 6, 2, and 1 in these three spots. Anybody? Can I have 6, 2, 1 here? Well, let's see. I tried to grab 6, 2, and 1. We know that that sum of digits is divisible by 3. Well, I need an even number here, so maybe I would choose 6 here. But the problem is, okay, I need an odd number here, so maybe I choose 1 here. But this number had to be odd, so I can't put 2 here, right? And the same problem happens, right? I have 2 even numbers and 1 odd. So I actually can't have this in my first 3 numbers. So this actually won't work for my first 3 numbers. And for the same reason, this won't work for my first 3 numbers. Would this work for my first 3 numbers? 5 and 3 and 1? Good. Yeah, Amelia's exactly right. Nope. Yep. I'm getting no from Amelia Maria. Thank you. So no, right? Because one has to be even, the middle one has to be even, and then these are all odd. Very good. Thank you. Good. So actually, even though, yep, this is divisible by 3, and um, so even this number, though this number is divisible by 3, and yeah, I have digits that I could make up into this number, I can't make one that has this number be divisible by 2. And let's see, and I can work with a similar thing for 12. Let's look at 12 here. Let's see, we have this combination. I think we have some other combinations we could probably use here. So we had 6 plus um, 4 plus 2. We have 6 plus, well, 3 plus 3. Wait, is that all the sixes I have? What else am I missing? That might be it. Is that it? I think that might be it. Stop me if I'm wrong. I think those might be the only ways that I could get to 12 with the numbers that I've gotten here, but let me know if I'm missing a case. Okay, so great. So I think those are the only ways I can get to 12 with the digits that I have without repeating anything. And so let's see here. If I look at these 3 numbers, remember, I need 1 even and 2 odd. So that could work. I have 1 even number here and 2 odd, but this one won't work, right? So potentially I could have this thing satisfying this. But this number, so what about, okay, so I could do this, right? 6, 1, 5. Sure. What's wrong with this? It's tricky. I'm being real tricky. 5 has to be the 5th digit. Jason's on it. He knows what's going on. He's like, got all my tricks. I can't have 5 here. 5 has to be over here. I already used 5. 5 we already determined. I can't have it 2 places. So in fact, I actually can't have this thing either, right? Okay, so I actually can't use that because 5 was already spoken for. I just didn't write it down. Okay, last case here, we said that was possible, was we could add 6 and 5 and 4 to get 15, but we run into both of the same issues we had before, right? I have 2 even numbers and 1 odd, and hey, that odd number is 5, and I've already used 5. So I actually can't get any of these things, and the only way that I can get something divisible by 3, so let's write this down, in these first 3 digits is by using the numbers that we had before, 1, 2, and 3, right? So good. So what we just reasoned through using our common sense. So we um, what do we say? We just found out. I'll say we must have the digits 1, 2, and 3 go in the first three spaces. And 2 has to be in the middle, right? Okay, great. So that actually limits our choices quite a bit. Next question down. Sorry about that. Reorient myself here. Okay, so that actually limits things quite a bit. So what we deduced was we already know where 5 has to be. We agreed about that quite a while ago, right? So we said 5 has to be here, and we know 2 has to be here. So now this can be 1 or 3, and this could be 1 or 3. And now this number could be 4 or 6, and this number could be 4 or 6, right? So that actually gives us not as many choices that we would have to test, right? So now, if I want to use guess and check, well, I can do, well, we already have two solutions, right? We have, so let's see, we have two solutions that we put way at the top. So our two solutions were, let's see, get it down here. We had, let's see, I think we had 1, 2, 3, 6, 5, 4, and we had 3, 2, 1, 6, 5, 4, I think, right? These were my two. 1 second there. So we only now have to check 3, 2, 1. These were my two solutions. So if we wanted to know, are there any other solutions? We only need to check two other things. Right. Keep having to move stuff down. Okay. And those two other things were, let's see, just if I mixed these things up. If I put 4, if I move 4 and 6, 4 and 6. Right? Those are the only other options that we said were possibly available. And so now let's just check these guys. That's not a testing two cases, not so bad for guess and check. Guessing if we would have just guessed and checked everything, it would be 6 times 5 times 4 times 3 times 2 cases, which is a lot more to guess and check, right? So let's see. Now we just have to check, do these things work? We know the first 3 conditions should be met, so these are going to be good. So my question is this divisible by 4? So is 34 divisible by 4? Sorry, I've been chat. Is 34 divisible by 4? No, and neither is 14. Great. Jason's way ahead of me. My writing is very slow. Thank you so much. And so is Mirna. Very good. We're on top of stuff. So neither of these two work. Neither of these are not divisible. So these are not divisible by 4. See, and you thought I was trying to trick you. And really, you got to the answer faster than me. See, look at that. Okay, very good. So, so what we just reasoned through, or common sense through, or whatever your favorite word to use through this, is that there are in fact only 2 license plates that fit this pattern. And we found both of them, and Dave and I had them. And so I'm so sorry you cannot join our cool club unless you find a state that has more numbers in your license plate. Okay. Very cool. Okay. Any questions about what we've said so far? Sorry, I got a little messy here. And thanks. Good questions or comments or thoughts? Okay. How are we doing? Is this problem fun or are we beating a dead horse? That's my question. Are we going too far? Are students allowed calculators to figure this out? I mean, that's your choice. For if you want to use an activity like this or problems like this in your classroom, that's totally up to you. Maybe it depends on the grade level that you're. Charlotte says fun, yay! Are that you're working with and what you think is appropriate and what skills you want to focus on for your students, right? So, for instance, if you want them to be getting really comfortable with divisibility rules and getting comfortable practicing, then maybe you don't want to use calculators. But if you're really just trying to get them through the logic of, so for instance, if you're just trying to focus on, hey, just find a solution for students that might be a little bit younger, or sorry, that yeah, that might even be younger and not really super comfortable with divisibility rules or know all of them, then yeah, maybe you want to use a calculator. But for maybe a more advanced student, like a middle school student where you're trying to get them to remember all of the divisibility rules, then maybe you don't want to use a calculator. So you're really actually having them try to ingrain those tools. Um, or maybe, you want to take away some of that cognitive load of remembering the divisibility rules, and just have them work through the like logic and the reasoning or common sense or whatever you want to call it that we were talking through here, to see if there's any other solutions. And maybe you want to allow a calculator, but that's kind of your choice. Definitely. I hope that makes things make sense. Good. Questions? Other questions so far? So great question. And I think for things like this, um, yeah, I mean, part of it is, yeah, kind of understanding and working with these divisibility rules. So yeah, probably just, doing a lot. I think using a calculator gets the students to really just think about only using guess and test. And I think, getting comfortable and understanding how these rules work, kind of intuitively, or having them ingrained as that common sense that we now kind of are able to use a little bit clearer, is a great strategy. Okay, so if we're still having a little bit of fun and we're not dying, so let's see, where are we at time? Actually, that's a good question. I can't remember what our next schedule is or what the scheduled timing is at here. Dave is probably a good point.
I am, yeah, yeah. Uh, I will look at the schedule where it says that you have till
Well,
12:05, so a little
which
less
is
than 10
one of
minutes. Yeah,
a little
105.
less than 10 minutes. Okay, cool. So then, yeah, let's maybe just think about the next question. I have some other questions on here that are of a very different uh, uh, kind of more related to place value. But maybe kind of changing gears for the last 10 minutes is not so great. Okay. So good. So the next, so we can kind of then a nice thing about these problems is, of course, like especially if you're using this for earlier students, you might want to start something like, instead of having a license plate with six numbers, maybe you want it to be something with four numbers, or starting off like a little bit smaller and then building up till they get comfortable with some strategies. We kind of dove in hard here with six digits, but you can start off smaller. And then we can also kind of extend with an activity like this. So now let's think about, what if we had, oops, sorry, I moved things around a little bit. I meant because I ran out of space. Let me move this out of the way. Good. So now let's see, we had six digits in the last problem, right? When we were talking about license plates. But let's switch things up a little bit. And let's say that here, Dave posted his amazing license plate number on Facebook. He got a comment from his friend Natasha. Um, and she is also into math. And she said that her social security number has the digits 1 through 9 and has similar properties. So in this case, that means so these first two digits are divisible by 2, the first three digits are divisible by 3, and so on, all the way to, we have our first 6 digits are divisible by 6, and it keeps going. So our next 7 digits are divisible by 7, and 8 digits are divisible by 8, and 9 digits are divisible by 9. So we're just extending on the same exact reasoning we had before. We use each digit exactly once, the digits 1 through 9. And we are going to have the same. We want to find a number that fits this uh, this pattern. So what do we know so far? Are there any strategies that we can take from the previous problem where we had 1 through 6 and extend to here? Are there any strategies or just things we learned? Even and odd. Oh, good. We learned about even and odd, and I think that is still gonna extend. Thank you. So very good point. So let's see. These would be our odd digits, and these have to be even. I think because right, because this has to be divisible by 2. This has to be divisible by 4. This has to be divisible by 6. And then this has to be divisible by 8. Exactly right. So these should all be our evens. So the even, and these are odd. Very good. Any other ones? Oh, 5. I see Maria put 5 in here. So good. So last time we also said, maybe I'll even label these positions, just so because there are so many, it's hard to visually. So this is 1, 2, 3, 4. Good. So in our fifth position here, that number has to be 5, right? Because that thing had to be divisible by 5. Very good. So that's still going to fit, which is very nice. We have our even and odd. Any other things that we took away? I think that's the main stuff that I had too. So I'm trying to think if there's anything I'm missing. This could, of course, could be other things that I didn't mention because you might have had other great strategies um, that I didn't point out explicitly. Very good. Okay, so maybe I'll give you a few minutes to play around with this one. One question I had when I first tried this, I tried one thing that I'm curious if you all were try as well. Um, but so I'll give you a few minutes to play around with it just to see if you can even can come up with any potential solutions. Good. I see a guess in here. People guess the same one. Cool, cool. Let me see. Mhm. Okay, so I see a couple of people guessing the same number, which is cool. Uh, I found a solution, and it's not one of these, but I actually didn't show whether or not this one works. So let's try. We can test these at least one or so solutions together. Um, Here's my question. Actually, this is good. Okay, so when I first tried, I'm curious if anyone else tried this. Or did anyone come up with any observations in their strategy or try anything that maybe didn't work in this particular thing before we test some answers? Oh, something went wrong on my screen. Oh, I'm sorry. Oh yeah, wait, what's going on? Oh, I'm sorry. Oh, thank you for pointing that out. I'm accidentally minimized something. That was my bad. Where did it go? Mice. Good, good. Thank you, Amelia. What was going on? Yeah, I don't know. Sorry, let me find it. Let me bring it back up. There it is. Okay, is that better? Can we see the screen now? Really? I lost the chat, but maybe we see the screen. Oh, it's good now. Thank you. Okay, great. Good. Like, can only have too many things on the screen. Perfect. Okay, so I found a solution that was a little bit different. Yeah, thank you. Um, Good. I had oh good. So I found a slightly different solution. The first thing I tried, I was curious to see if anyone else tried this, was we do know that we have these two solutions that we found for the previous problem, and the first batch of rules kind of fits the same. I was curious if anyone tried this as the first six options, either one of these, one, two, three, six, five, four, and then use the remaining digit seven, eight, nine as the last three digits, or vice versa, three, two, one, six, five, four, and then use the remaining three. That's the first strategy I used. It didn't work. So I'm glad you didn't. But I did try that. I don't know if that made sense, but I tried to put what I tried was one, two, three, six, five, four, and then tried different permutations of seven, eight, and nine in these three spots. Um, because I knew that the first six would work, and then as long as the last three worked, we'd be fine. It didn't work in either of the cases, but I was just curious if anyone else had tried that strategy. I thought it was not a bad strategy, but it didn't work. So glad you didn't waste your time if you didn't do that. Um, Great. Okay, let's maybe at least test one of. Oh, if we have a minute. I know I'm a little bit out of time here, but maybe we can test at least one of these answers for good measure here. Um, let's six, five, four, seven, two, nine, and nine, two. Good. So I think this is one solution. The five rule seems good. Let's see. This is definitely divisible by two. This is divisible by three because three plus eight plus nine, or sorry, three plus eight plus one is 12. Let's see. This is divisible by four, divisible by five. Uh, and now, so one thing that we notice is this is different than the six-digit numbers we had before, but that's okay because we have a new number we can use, right? So that kind of helps things. So let's see. We want to see if this is divisible by six. It's definitely divisible by two, and we just need to check that this is divisible by six, or sorry, by three, and it looks like it is to me. We need to check that this is divisible by seven. And there are some divisibility rules for seven. Um, but they're very weird because there's not a great divisibility rule for seven that we usually teach. So this is where I would say, yeah, just use your calculator, and that seems to be divisible by seven. Um, and then for eight, we want these three numbers to be divisible by eight. So 472, is that divisible by eight? And that is. So that's divisible by eight. And then the last, we want the whole thing to be divisible by nine. So that means the sum of these digits should be divisible by nine. And again, if any sum of these bunch of digits is divisible by nine, then all of them have to be divisible by nine. So that should be good. So I think this works. So I believe this is a solution. I believe I found a different solution as well, and there might be some other ones that worked in the chat as well. So I know there's got to be at least two. There might be more on this one. I'm not completely sure what the max number is of solutions of this thing. So there's a fun little extension that I'll kind of leave you with. Is, of course, if we move this up to 10 digits and we made one of those digits zero, kind of there's a fun little quick extension to this problem as well. So I know I'm out of time and I don't want to take too much more, so y'all can have a break. But what I'll do is I'm going to put my email on the screen here real quickly in case anyone has any questions. I put in the beginning of the chat, I can put it again, kind of a worksheet with these questions on them. There's some version of solutions in certain places that I can help you, that I can maybe get for you if that's something you would like, or answer any questions at all. You can always email me. I love, working with Dave and this Navajo Math Circle, and talking to you all. So again, thank you all so much for joining me on a Saturday and for being active and engaged and stuff. I know you're all tired, so I really appreciate it. Thank you, and I hope you all have a wonderful day and a good rest of your event. Yeah, thank you all. I'll stop sharing here, but you can also look me up on Navajo Math Circle and stuff like that and find my info if that's something you need. Okay, thank you.